MakerSnack.
The Swift sign and more, creating a pixel art animation display with the Adafruit Matrix Portal. Now this is a very easy project, it requires no soldering, and if you like some of the animated images shown here, then this is a fast project you'll have done in no time. And if you're comfortable with tools like Photoshop, you can add your own pixel art as well. All you'll need to do is change one line of Python code. Now the parts that you'll need include an Adafruit Matrix Portal. This is essentially the computer that runs the project. It's a little board designed to snap easily onto most LED displays sold by Adafruit and others. It'll work with any LED display that's Hub 75 compatible. Now this board also runs CircuitPython, and although we won't use the wireless capabilities in this tutorial, the board's also got Wi-Fi. Now you'll also need an LED display. This tutorial and all the images will work with any of the 32x32 displays sold by Adafruit. I'm using the 5mm 32x32 display. Adafruit also sells a 6mm and a 4mm display, as well as a bunch of displays in dimensions other than 32x32. And you'll also need a micro USB data cable. Be 100% sure that you're not using a charge-only cable, or you won't be able to load the software onto your Matrix Portal. My display is attached to my magnetic whiteboard. If you want magnets, Adafruit sells those as well. And if you have an Alexa smart plug like this one, you can also set your display to go off from a voice command.
Alexa, get Swifty.
Okay.
First, let's assemble this bad boy. I'm using the 5mm panel, and when you open the box, you see that it comes with this ribbon cable. Now, we don't need this. The ribbon cable would allow you to connect the LED panel to an Arduino shield or a Raspberry Pi hat, but we don't need that because the Matrix Portal plugs directly into the LED panel. Now, we will need this black and red cable. The cable has two identical white 4-connector power plugs. We just need one of them, and we'll leave the other one loose. Now, there's only one socket for this plug in the LED panel, that's this one here, and the plug can only go in one way. Look for the GND marker on the silk screen, that means ground, that's for our black wire, and the black wires should be at the same end where you see GND. Now the red wires are the power wires, they should be at the VCC end, and there's a little plastic tongue piece on the white plug of this cord that goes on the outside of the socket, and it'll snap in nicely so it doesn't come back out. There shouldn't be any need to force this. Now when you take a look at the Matrix Portal board, you'll probably see the two holes that accept the enclosed screws have orange tinted film over them. Just peel this off. Now let's take the black and red terminal connectors at the end of this wire and use the screws that came with the Matrix Portal to attach the black wire to the GND hole and the red wire to the 5V hole. Now we're ready to plug our Matrix Portal board into our LED display, and the plug on the display is sort of diagonal from the plug we used to attach the red and white power cable, and into this plug we'll insert this connector on the underside of the Matrix Portal board. It has two rows of pinholes. This is the standard connector for Hub 75 displays. You'll notice the Matrix Portal board hangs a little bit over the edge of the LED display, but the board should plug into the display pretty easily and you won't need to force it. Now let's download some of the software that we need for this project. First, let's install the latest version of CircuitPython on our board, and you can find this by visiting circuitpython.org from your browser, then click Downloads, and in the search box we'll type the name for the board we want, that's Matrix Portal, and the only option that shows up is Matrix Portal M4, that's the board I've got, so click that image. And at the time I'm recording this, the latest version of CircuitPython is 6.0. You should be able to use whichever version comes up first on this page. That should be the latest version. Then click the download button. I'm going to save mine to the desktop. And while this file will install CircuitPython, we also need to install a selection of library files that extend the CircuitPython language to do all the cool stuff that we want to accomplish with our LED display. So we can find the libraries we need by clicking on the Libraries tab at the top of this web page, and the first version you see should be the one that's compatible with the CircuitPython file that you just downloaded. So click that first button. It'll save it as a zip. I'm going to save mine to the desktop as well. Then I'll minimize my browser, double-click the zip file to extract it. This gives me a folder with a very unfriendly name, but I don't need the zip file anymore, so I can throw this zip file into the trash, and we'll work with this folder that we just decompressed in just a bit. I'll leave it on my desktop for now. Now let's power up our board and display and install CircuitPython on it so it'll be ready for our animation code and our bitmap graphics. The Matrix Portal has a USB-C connector. Make sure that you have the right cable, and this should be a data cable, not a charging-only cable. And plug the other end into your computer. And hey, when you do this, it's surprise and delight time. The Matrix Portal runs a built-in program with pixel sand. And if you tilt the board, the accelerometer in the board will detect motion, and the pixels will slide to the lowest end of the board, just as if you were using one of those sand toys. Very cool. But we're about to get rid of this program so that we can display our own animations. If you want to reinstall this at a later date, this is an Arduino program. Here's the first page in a series at adafruit.com that describes how to install the Arduino software, the required libraries, and the Pixel Dust program. Now to install CircuitPython on the Matrix board, first make sure that it's plugged into your computer, and then double-click this reset button here in the upper left-hand corner of the board, and when you do that, this light on the board will turn green. If it turns red, try double-clicking again. If it's still red, check your USB cable to make sure that it's a data cable. Try another USB port, but this should work. And when you do that, take a look at your desktop and look at that. You should see a new volume named Matrix Boot right on the desktop. It's just as if you plugged a USB thumb drive into your computer, only the Matrix Boot is our Matrix Portal board. Now I'm going to drag Matrix Boot over to the right, then I'm going to drag and drop this first file that we downloaded. That's the one named Adafruit-CircuitPython, and it ends in .uf2. And when you drag it into Matrix Boot, the file will copy over, then Matrix Boot will dismount from your computer. If you have a Mac, you'll see this message that says that the disk was ejected improperly, but that's totally okay. You did nothing wrong. This is to be expected. So if you see that, you can go ahead and click close. But then if you wait a bit, you'll see another volume is mounted, and this time it's called CircuitPy. Now this is also our Matrix Portal board, but now it's recognized as being set up to run CircuitPython. Congratulations. Now let's get the project files we need. Now this will include the code.py Python program that runs the animation, as well as the BMP files that contain the images that we want to show on our display. Now we can find all of these files by returning to the browser and visiting the web address github.com/Gallagher. That's my last name, but it's a weird spelling of Gallagher. It's got a U in it, like Gallagher, then slash, then Swift, the dash character, and sign, all lowercase. Now the README below has links to the parts that I purchased for this project, and here are all the files that we'll download. So let's click on the green code button here to get all the files in one zip file. So we'll click download zip right here. I'll save this to my desktop, minimize my browser, double click the zip file to decompress the file into a folder. Then you can throw out the zip file. We don't need that anymore. Now we're going to take a look at the code.py file that we just downloaded. That's the Python program that controls the LED display. And I'll show you how we can easily modify this program. And to do that, we'll take a look at the code.py Python file in a free program named Moo. Now the Moo program will allow us to write and edit Python programs, just like Microsoft Word allows you to edit word processing documents. Now, if you don't have Moo, you can download it for free at codewith.moo. Just click this download link, but if the web page shows an alpha version first, skip these. They tend to be buggy. Then instead scroll down to the icons for Windows or Mac, and you can download and install the version that's right for you. I already have Moo on my computer, so I'm going to open it up now. I'll double-click the Windows title bar to expand to full screen, and the tab in the left-hand corner is a blank area where we can write a program, but instead, we'll load the code.py program that we just downloaded from GitHub. So let's click on the load button, and I'm going to navigate to the folder that I decompressed from my GitHub download. It should be named swift-sign-main. I've got that right here on my desktop, and I'm going to go into this folder, and inside find the code.py file, and double-click that to open it. Now this code was adapted from a project by the wonderful and skilled engineer Liz Clark, also known as BlitzCityDIY, and there are links to the original project in the comments in this code. I've modified the project a bit to be more generic, and I've also included some additional comments to help beginners understand what's going on in the code, but you don't really need to understand the code to get things to happen or even to customize this program. But first we'll need to add some special CircuitPython library files to our Matrix portal, and these library folders and files will contain extensions to the CircuitPython language, so we can use CircuitPython to work with the Matrix portal and our LED display and get it to flash our bitmap animations. Now I've listed the folders and files that we need in the comments at the top of the program, so we're going to put them in a folder named lib, all in lowercase. Then once we've created this folder with the files that we need, we'll drag it over to the Matrix portal and we'll be good to go. So here's how we set up the lib folder that we need. Let's head over to the Finder if you're on a Mac, or similar if you're on Windows, and I'm going to create a new folder. Make sure that you name it lib, that's all in lowercase, and I'm going to go inside of this folder and I'm going to leave it in this window. But then I'm going to open up a second window. I'm going to navigate into, for me, it's going to be the Finder. That's the space where I downloaded and unzipped the library files that I downloaded from the CircuitPython website. Now for me, the folder that was created when I unzipped this file is named Adafruit-CircuitPython-bundle-6.x-mpy, and a number that represents the date when this folder was updated. Now your folder might have a slightly different name, but that's totally okay. That just means that CircuitPython has been updated since I recorded this video. But let's go inside this folder, and then inside that you'll find another folder named lib. Go inside that folder, and this folder contains all of the library files that are available to extend the CircuitPython language. Now we don't need all of these extensions. In fact, this entire folder is too big for our Matrix portal. So what we're going to do is we're going to find and copy those folders and files that we need for this project. We're going to put them inside of our empty lib folder, and then we're going to copy this repopulated lib folder onto our Matrix portal. So on the left side in the code that you see in Moo, I've commented out the folders and files that we need to find. Now they're listed alphabetically. So I'm going to scroll in the files that I downloaded from Adafruit to find the first one. That's Adafruit_bitmap_font. And the Mac shortcut key to copy the file rather than just move it is is to hold down the Option key and then drag it to the destination location. I'll let go. You can see that I've just made a copy of that whole folder, and then I'll repeat this for all the additional folders and files that I've listed in my comments over here. Now I'm speeding up the video here, but you should copy over the folders named Adafruit_bitmap_font, which we just did, then Adafruit_bus_device, Adafruit display text, Adafruit ESP32SPI, Adafruit image load, Adafruit IO, and Adafruit matrix portal. Now that's the 7 folders that we need. We also need 3 files. Those are Adafruit requests.mpy, neopixel.mpy, and simpleio.mpy. And you know what, as I create the voiceover for this video, I'm realizing that I didn't copy the right neopixel.mpy file. I copied over neopixel_spi.mpy, so make sure that you get the right one. That's neopixel.mpy. Apparently this didn't impact my project, but I went back and updated this anyway. So now let's get this lib folder that we just set up onto our matrix portal. So I'll head back to the desktop. I'll find this lib folder that I just created. I'm going to expand it using the expansion triangle, and the folders and files match what I have listed over here in the comments in Moo. So I'm going to click on this lib folder. I'm going to drag it into the CircuitPy volume, which is our matrix portal. It'll take just a moment to copy that folder over, but I've sped it up here. And now, my friend, CircuitPython is updated with all the extensions we need for our project. So let's get our project files on our matrix portal too, so it can start to do something. Now those are in the folder we downloaded from GitHub. Now I saved my folder on my desktop. That's the folder named swift-sign-main. So find that folder on your computer, go into that folder, and then select all the files that you have in here except for the README file. So on the Mac, I'll do that with a Command A. That'll select all, but then I'll hold down the Command key and I'll click on the README file to deselect that. And then I'll click on all the files that I've just selected, and I'm going to drag them into my CircuitPy volume. Now I'll speed up the video where we copy this over, but you may start to see the LED matrix animating right away. But let me show you how we can select different files to animate by modifying our code.py file in Moo. So now if we scroll down in Moo, we'll see this line that says bitmap_name equals, and then in quotes it says full-animation. Now for me, this is in line 61. There's a chance that it's in a different line if I've modified the code since I originally recorded this video, but it should be in roughly the same location. Now this phrase full-animation is the name of the animation that you might be seeing right now on your LED screen. Now just above this in comments, and comments in Python start with the number sign or the hashtag mark, you'll see the name of the 8 files that I've included with this project. So full animation shows the Swift logo, the Adafruit logo, the Raspberry Pi logo, the Arduino logo, and a pulsing Excel icon. Now those are all topics of videos you can find on my YouTube channel, but you'll see there are other file names here. There's Swift is just the Swift logo, PartyParrot's matrix is the animation from Liz Clark's awesome and fun PartyParrot project. Ghost animation is an animation of a ghost that I found and modified online, so he's winking as he bounds along. So before we change animations, let's make sure that we're saving this code.py file to our matrix portal, and then we'll modify it to show different animations. Now first, I'm going to get rid of this Untitled tab that I have in the background here. I'm going to click on the X next to Untitled. That will close this blank file. We're not using that. And then I'm going to double click on the code.py tab, and this brings up the Save As dialog box so that I can save this to my CircuitPy volume. So I'll find that CircuitPy volume, that's my matrix portal, click CircuitPy to select it. I'm going to save it right at the root level, so not inside of any folder. And what you want to do is you want to make sure that you're going to name this code.py. Now that's all lowercase, no spaces, no capitalization. That's the name of a program that will run automatically on the matrix portal, code.py. And if you don't give it this exact name with this exact spelling, the program will never run. So once you've got this name typed in, press save, and if you're asked to replace what's already there, click on replace, and you should see your LED display starts animating. Now sometimes you have to press the save button in Moo a second time. I'll do that now, but this should be what you're seeing. And if that's the case, congratulations, you've got animation. Now let's try out some of these other animations. So I love Liz's PartyParrot, so I'm going to select the string PartyParrot matrix. I'm going to copy that, and I'm going to paste it over the word full animation in between the double quotes. Make sure the double quotes are still there. That's in line 61 in my code. Then I'm going to click on the save button, and this restarts the matrix portal. It executes the updated code.py file, and look at that. You've got a groovin' bird ready to impress your friends. Now let's get ghostly. I'll copy this text that says ghost animation. I'll paste it over PartyParrot's matrix. I'll save again, and this little guy is friendlier than Casper. Look at him go. Now maybe you're an iOS developer and you just want the Swift, so you can highlight the word Swift and paste that in between the quotes, save again, and you're Swiftin'. Now what if you want to change the speed of animation? Well, I've got a constant up here that you can modify at the top of your code. Mine's in line 39. 0.1 means there's only 1/10 of a second in between animation frames. Want to slow this down to 2/10 of a second? Change 0.1 to 0.2, click save, and you can see that the animation slows down by half. Now this is not meant to be a Photoshop tutorial, but I wanted to show you how I created the animation files. So I did use Photoshop, but if you browse around, you might find some other free products that you can use. I'm going to open up one of the files from my project in Photoshop. That's this file called raspberry-adafruit-animated. And if I zoom in on this image, you can see that it's 32 pixels high. Now, even though it's long, every 32 pixels is the width of a different frame in the image that you see on the LED display, but it's saved as one long image file. Now, when saving, two really important things to be aware of. One, if you're using Photoshop, be sure that you go up under the Image menu and select Mode, Indexed Color. Otherwise, the file you save just won't work. Also, you'll need to save the file as an 8-bit BMP file. So to do that, go up under the File menu and select Save As. Make sure that you select BMP as the format. You also want to make sure that you have the .bmp extension, that's with lowercase letters, and make sure you know where you're saving this. And when you click on Save, you'll see BMP options. Make sure that you select Windows and 8-bit. Anything higher than 8-bit won't show properly. Now, once you've saved this to your computer, you can drag this over into the root level of your CircuitPy volume, which is your matrix portal. Just remember that if you created a new file with a new name, you want to return to your code.py file and you want to rename the line of code that has the bitmap_name. So just put the new name of your file in between the double quotes, just like we showed you previously. Then you want to make sure that you resave code.py to your CircuitPy volume, and you should see your new image. Now that's all I've got on BMP creation, but Adafruit has a great guide that you can consult online, and if you browse around, I'm sure you'll find lots of fun BMP animations, maybe some other YouTube tutorials so that you can really make this project your own. And that's all I've got for you on how to create an LED display using the Adafruit Matrix portal. I hope you enjoyed the video. If you did, please tell others about the channel, and if you build something, post a photo or a video to Twitter so I can brag about your work. Have a great day, and make something awesome.